Algebra 2, 2.8a, Prove conditional statements. Conditional statements are if-then statements with conditions. So if x is less than 5, then x has to be less than 6. Well, that makes sense, right? And if p, then q. And the p is called the antecedent, and the q is called the consequent, like consequences. These statements are also called conditionals. Now, to prove the conditional, we assume that the p part is true. We assume that this part is true. And then we try to show that it'll lead us to the q, to the consequent. Then we can come to the conclusion that if p, then q is true. Solving an equation is a good example of proving a conditional. Now, to prove if 10x plus 5 equals 25, then x equals 2, the first thing we're going to do is assume that the statement is true, that 10x plus 5 equals 25 is true. Our assumption is our hypothesis. We use the principles, the rules for solving equations to get x equals 2. We can use a proof table, like this, which is also called a column proof, to list our statements and the theorems, axioms, or definitions, principles that let us make each statement, our reasons. So, number 1, we have 10x plus 5 equals 25. Well, that was given, and that's our hypothesis that we're going to assume is true. 10x equals 20. Using the addition property of equality, we could subtract this 5 from each side, or add the negative to each side, right? The negative of 5. And that would get us 10x equals 20. Then we would have x equals 2 using the multiplication property of equality to multiply both sides by the reciprocal of this coefficient, or we could use the multiplication property to divide both sides by 10, right? And that 20 divided by 10 would give us 2. So that brings us to number 4. If 10x plus 5 equals 25, then x equals 2. And we've proven it because of statements 1, 2, and 3. See? And it slowly led us there. So each statement is backed up by a reason. And if 1 is true, then we're led to number 2. If 2 is true, then we're led to number 3. And if 3 is true, then we conclude 4 is true. So we went from 1 to 4 to prove. See? We can also write this as a narrative proof. A narrative is a spoken or written account of connected events, or a story. So here it is as a narrative proof. Assume that 10x plus 5 equals 25 is true. Then by the addition property of equality, adding a negative 5 to each side of the equation, it follows that 10x equals 20. And by the multiplication property of equality, multiplying both sides of the equation by the reciprocal of the coefficient 10, by that 10, as 1/10, we get x equals 2. Therefore, 10x plus 5 equals 25, then x equals 2. That is a narrative proof. It's written like a story, isn't it? An if-then statement is only false if the antecedent is true and the consequent is false. So if the first part is true and the second part is false, then it's false. If I said, if my dog eats cat's food, then my dog is a cat, well, my dog has eaten cat food, but that doesn't mean he's a cat. The antecedent is true, but the consequent is false. Therefore, this whole statement is false. See? It can also be used to prove a point. If Emma's wrong, I'll eat my hat. Or you might hear someone say, well, if he's wrong, I'm a monkey's uncle. The antecedent is false, we make no assertions about the consequent. So if the first part is wrong, we don't even think about the second part. And assertions are statements of fact or belief, okay? So if the first part is wrong, then we don't even make any statements about the facts of the second one, see? If Emma's wrong, I'll eat my hat. This asserts that I don't believe Emma's wrong. I really believe she's right. And I'm so sure that she's not wrong that I say I'm gonna eat my hat if she is wrong. And this is just a saying. We know I wouldn't eat my hat. It's just a saying. Like, I'm a monkey's uncle. Okay? So here's a funny one for you. The antecedent is if my nose is 12 inches, and the consequent is then it's a foot. So that is a funny if-then conditional statement, or conditional. So maybe this will help you remember it. Okay? So, all right. Our next video is 2.8b. We're going to write and prove converses. And you can go to this Algebra 2 playlist to catch up a review or study for tests. I'm going to add this video to it now. And there's also going to be a link to my Algebra 1 chapter playlist of inequalities and absolute values. And hopefully that'll help you too, okay? All right, we're going to move on to converses. And I hope I'll see you there. Bye.